Hi guys, welcome back to the channel. So today we are going to be solving today's Leetcode question, which is freedom tribe. We are given two strings, one is ring and then the other string is key. We need to find the minimum number of steps which are required to get the key using ring. Suppose let us think this is kind of like a wheel. We need to find the key which is present in this particular wheel. Now, when we want to find any character which is present in the key, we need to make sure that we should turn this wheel either clockwise or anti-clockwise, and then we need to get the letter at this particular point, which is here, and then we need to press the button. Then we'll get that particular character. Suppose we want G as of now. Now we'll make sure the G is present at the top of this, and then we'll press again one button. So the number of steps required for G is going to be 1, and then again we want D. So for D we can rotate anti-clockwise like 1, 2. We can rotate twice anti-clockwise, or we can rotate clockwise so that we'll get the D. So those are the two different steps we can take. Like we can move the wheel towards the anti-clockwise, or we can move the wheel towards the clockwise, and then we can make sure that D is present, and then we are going to take the D, and then again we are going to press the button so that we'll get G and then D. So this is the question. Now let us say this is the starting point and we are given G. Now we want the G. So for G it is already present, so we'll press the button, and then there is one more possibility. Instead of taking this G, we can take this G. That means the number of steps required is 1, and then after taking this G we want D, so we can either take this D or this D. So these are the two different possibilities. We can pick any one. We can pick the possibility which has minimum steps, and then we are going to take the minimum of these two steps, and then we are going to store the answer. So now, when I want any character which is present in the key, I will get all the indexes which are present in the ring. That means when I want G, I'm going to store 0. Why? Because it is present at the index 0. And then when I want D, I'm going to store the index of 1 and then 2. Now, whenever I have some particular index, I'll move from this index to whichever key I want. Suppose let's say I want the key of G. That means I can pick any one of the indexes which is present here. And then I want D. I can pick any one of the indexes which is present in D. Now let's say this is the index which is traversed previously. Now we'll go to this particular index which is 1 or 2. Now when we are moving from I to 1 or 2, we'll calculate the cost required for this. That means suppose let's say I move from G to D. It requires 2 steps. That means we are going to rotate the wheel one step and then again 2 steps. That's why we are going to calculate the cost required for this, and then we are going to calculate the minimum of either if we do via anti-clockwise we'll get one cost, and then if we do via clockwise we are going to get one more cost. We are going to take the minimum of those two costs, and then we are going to pick that particular index. We can pick either one or we can pick either two, and then after picking one and then two, we are going to traverse again for the next index which is present in the key. So this index will be pointing towards the index which is present previously in the ring, and then a key will take care of the indexes which needs to be traversed, and then we want the index where we need G or D. So we are going to use this G and D indexes, and then we are going to pick the index, and then we are going to calculate the number of steps required for this, and then we are going to move. So for this, let us see the code and try to understand. We are going to use the DP for this. So first we are going to take the DP, and then the n is going to be ring size, and then we are going to take the adjacency where it is going to store the characters, and then what are the indexes which have this particular character. Suppose let's say if we take 0, that means A is a character which we have for this indexes. Suppose for this it is going to store all the indexes which is present in the ring, and then we are going to return the number of key dot size and then the number of steps which needs to be revolved with this particular wheel. This key dot size we are going to add. Why? Because suppose let's say if we if we do the clockwise rotation or anti-clockwise rotation, after getting the character which is present in the top, we are going to press this particular button for each key which is present in the key. That's why we are going to add key dot size, and then we are going to do the recursive function which is going to be like DFS. And then we are going to start with 0 and then 0 and then key and then ring key and then adjacency. So for this, we are going to take three things. One is previous index, the other is index, and then ring, key, and then adjacency. So this previous index is going to be the previous index which is taken for the ring. And then the index is going to give us the character which we want at this particular key. We want the key, but as of now, we are in the ring of with the previous index. Suppose let's say we are writing the base condition here. The index is key dot size. That means we have already done all the characters which needs to be traversed in the key. So that's why we are going to return 0. And then let's say if this particular subproblem is solved. Suppose let's say the previous index is some G or D, and then now the index which we want is 1, uh, which is 1, that is D. Now if this particular problem is already solved, then we are going to return answer which is present in the subproblem solved. And then now we want this particular node which is key of index minus a. This is the node I want, and then we are going to store the answer which is going to be minimum answer which we can do with different traverses. And then this cost is going to be, suppose let's say we have previous index, and then I have uh, the next index which is present in the ring is going to be here. Now I need to traverse from here to here. There is going to be some cost when we are traveling from previous index to current index. That is going to be some rotations like anti-clockwise or clockwise that we are going to store in the cost. And then let's say if the node which we want for this key is same as the ring which is present in the previous index, that means we have same character which needs to be present. So we'll not do anything. We'll not require any steps required. That's why we are going to do the DFS with index traverse. That means we'll increment the index without adding any cost, and then we are going to maintain the temp. And then there can be different possibilities. Suppose let's say we want this node, and then these node indexes are present at this particular node index. That means suppose let's say I want D. That means D is present with index of 1 and then index of 2. That means D and then D. For this I need to do the steps 1, 2 and then 3 for this particular D, and then for this it is going to be 1, 2. So that's why we are going to pick each index which is present with this node, and then I'm going to calculate the minimum index which is present, which is node index and then previous index, and then I'm going to take the maximum index which is with the node index and then previous index, and then I'm going to calculate the minimum cost required. That means if I consider with the like this, it is going to be maximum index minus minimum index, the absolute difference between maximum index and then minimum index. And then if we do by a clockwise, then we are going to consider n plus minimum index minus maximum index, and then for each index we will pick, it is going to be our cost, and then the previous index is going to be current node index, and then we are going to increment the index plus 1, and then we are going to take ring and then key and then adjacency list, and then we are going to take dp of index and previous index equal to temp, and then we are going to return the answer. So if we come to the time and space complexity, it is going to be big of n into m. Why? Because we are going to take index which is going to be our m, and then previous index is going to be n, and then this is going to be our one for loop, which is going to be like storing all the characters. So that's why it can be like n. Yeah, it can be like n. And then the space complexity is going to be big of m into n. Yeah, that's all for this video. Thanks for watching the video.